Hello, pretty pre-calc. Time for 7.5 solving trigonometric equations. Most trig equations have more than one solution. You need to consider how many solutions you're being asked for. It will be very specifically specified in a problem, but you need to pay attention to it. For instance, example 1 says principal values. Example 2 says 0 to 2 pi. These say all real values. We'll talk about that later. So you need to pay attention. What we've been doing in class, we've talked about identities, we've talked about double angle identities and sum identities and the Pythagorean identities. All of these are heading towards being able to solve equations with trigonometric functions. So we're going to work on that today. Little reminder, when we were talking about the inverses, sine inverse, cosine inverse, I said you need to restrict the domain so that there is only one place where a particular solution occurs. And that's what the principal values are. That's that limited domain for sine and tangent. It's quadrants 1 and 4. And for cosine, it's quadrants 1 and 2. And that way, each value of cosine, positive and negative, only appears once in the principal values. Each value of sine only appears once. And it's negative 90 to 90 for sine and tangent, 0 to 180 for cosine. So, algebraic methods including factoring and the identities we have used may be used. So I expect you to know how to factor and expect you to remember the identities we've done. I've put up a helper video. If you can't understand how I factored something, that helper video has slightly more step-by-step work so that I can just focus on the trig here and the algebra is in another video. So, example 1, solve 2 sine squared plus sine x minus 1 equals 0 for principal values of x expressed in degrees. So, in degrees, the principal values for sine are negative 90 to 90. So those are all, we're only looking for an answer in that range. And generally, well, sorry, I was going to say we might only get 1, but here I think we're going to get 2. So, never mind. Thing is, and this is what people have trouble wrapping their heads around, 2 sine squared x plus sine of x minus 1 is, algebraically speaking, for the purposes of our solving it, the same as 2y squared plus y minus 1 equals 0. And you know how to solve that kind. So that's what I've solved in my other video. If you factor this, you get y plus 1 times 2y minus 1 equals 0. That is to say, y is my sine of x. So I've factored 2 sine squared x plus sine x minus 1 into sine of x plus 1 times 2 sine of x minus 1 equals 0. By the multiplicative property of 0, if the product of two numbers is 0, then one of those numbers must be 0. And therefore we can split this up. We can say either sine of x plus 1 equals 0 or 2 sine of x minus 1 equals 0. If either one of these is true, then this is true. And then solve. So either sine of x is negative 1 or 2 sine of x equals 1, sine of x equals 1/2. You should know this, but I'm subtracting 1 here, adding 1 here, and then dividing by 2. So sine of x is either negative 1 or 1/2. Then you go to the unit circle, or ideally your memory. The place between negative 90 degrees and 90 degrees where sine of x is negative 1 is at negative 90 degrees. And the place between negative 90 and positive 90 where sine of x is 1/2 is at 30 degrees. So our two solutions are x equals negative 90 or x equals 30. And you can plug them both into the original. Do 2 sine negative 90 squared plus sine negative 90 minus 1, and it should give you 0, and vice versa. Example 2, solve sine squared x minus sine x plus 1 equals cosine squared x for 0 to x to 2 pi. This means a couple of things. First of all, we need to check, well, I'll show you what it means in terms of using the entire circle, but also this means our answer should be in radians. That's fine. All right, we've got sine and we've got cosine, and that's a little inconvenient. In some problems, it works out okay, but in this one, I would rather have it all in terms of sine. Fortunately, because of the Pythagorean identity, I can do that. So I'm going to leave the left-hand side of the equation alone for now, but I'm going to replace cosine squared with 1 minus sine squared. That's the first that's a corollary of the first Pythagorean identity. Now I want to get everything on the same side, so I'm going to add sine squared to both sides and subtract 1. So what I get here is 2 times sine squared x, minus sine of x plus 0 equals 0. I'm just realizing that the version on my helper video, I left out the 2, but that's all right, it's not a big deal. When you factor this, they both have, we can take out a greatest common factor, and you should always do that when possible. So we'll factor out sine of x. This turns into 2 sine of x minus 1. Set each of those factors, sine of x and 2 sine of x minus 1, equal to 0. Solve for sine of x. All right, so sine of x is either 0 or 1/2. Where is sine of x equal to 0? Well, it's equal to 0 at 0 radians and then again at pi over 2 radians, because we need the entire circle. We're not doing only principal values here, we're doing the entire circle. So at 0 and at pi over 2. And where is sine of x equal to 1/2? That happens at pi over 6 and at 5 pi over 6. So we have 4 solutions to that equation, and you can test them all. How do I know 5 pi over 6? The pi over 6, I hope you guys are all getting pretty used to the fact that that's where sine is 1/2 at the 30-degree angle, which is pi over 6 radians. Sine is also positive in quadrant 2, so I need to get the angle that's basically, that has the same reference angle in quadrant 2, and that's 5 pi over 6. All right. Most trig equations have infinitely many solutions. So when it says for all real values and doesn't limit you to only the circle or only the principal values, you need to say plus 360k or plus 2k for sine and cosine. And if it's tangent, plus 180k or plus pi k. Example 3, we need to solve this by factoring. So please, or sorry, factoring by grouping. So please, if you don't understand that, go watch how I do it on the video. But I'm going to factor these two separately. What I'm going to get is 2 times sine of x times 2 cosine of x minus 1. And then for this section, I'm going to get negative square root 3 times 2 cosine of x minus 1. That means my factors are 2 sine x minus 1 times 2 cosine x minus 1. And then I'm assuming that you can by now set this equal to 0 and solve for sine x. Sine of x equals 1/2, or cosine of x equals 1/2. Sine of x is 1/2 at 30 degrees plus 360k, because it's 30 degrees, and then again at 390 degrees, and then again at 730 degrees, etc. Cosine of x is equal to, oh, sorry, I'm not done. It's true at 30 degrees plus 360k, but then also, remember quadrant 2, it's true at 150 plus 360k degrees. Cosine is 1/2 at 60 plus 360k degrees. And also in quadrant 4, so that's at 300 plus 360k degrees. And that whole thing is our answer. And of course you could check these, plug them in for, don't plug in the 360, check the 30, plug it in for x, in all these x places and check whether you get 0. Sometimes you get inequalities. These are use the same techniques. And then to figure out whether you want to go above or below, basically you use the unit circle. So solving 2 sine theta plus 1 is less than 0. We'll go ahead and subtract 1 and divide by 2, and we get sine of theta is less than 1/2. So where is sine of theta less than, subtract 1 I said, I apologize. Where is sine of theta equal to negative 1/2? Well, that's at this, that is 30 degrees away, or pi over 6 away, into quadrant 3, so that's 7 pi over 6. And then 30 degrees away in quadrant 4, that's 11 pi over 6. Since it says less than negative 1/2, the y values, and the y values are the sign, y values are going down this way. So sine of theta is negative 1/2 here, and then it becomes negative square root 2 over 2, negative square root 3 over 2, negative 1. And then negative square root 3 over 2, negative square root 2 over 2, negative 1/2. So it goes below and then back up. So theta is between 7 pi over 6 and 11 pi over 6. And since that's a strictly less than, those are strictly. You could also pick some values in between there and plug them in. On the back, these are pretty much just practice problems. I'm definitely going to do them because I know they can be a little challenging, but I'm not going to spend as much time on them. So, number 6, this one is not that hard. You'll add square root of 3 to both sides, and then you will divide by 2, and you get cosine of x equals square root of 3 over 2. Principal values for cosine means from 0 to 180 degrees, because we were told degrees. And the only place in there where cosine is positive, square root of 3 over 2, is at 30 degrees. Tangent 2x minus square root of 3 equals 0. We are going to add square root of 3. And now, this is tangent 2x. Remember, that's not the same as 2 times tangent of x. And I told you we weren't doing the identity for tangent of 2x, and we don't actually need it here. What we're going to do is basically pretend that's something else. Pretend that's tangent of y. So if tangent of y equals square root of 3, well, where is tangent square root of 3? That happens at 60 degrees. And then it also happens at 240 degrees. The reason I'm putting this in a box is it's not part of the principal values, but we want to check it in case the final answer is. So y, I used y to replace 2x, so now I can put 2x back in there, and now I can divide both sides by 2. So x is 30 degrees or 120 degrees. 120 degrees is not in the principal domain, or the principal values for tangent, so the only answer is x is 30 degrees. This one, remember that you can use the Pythagorean identities, and that's what I'm going to do here. I'm going to change cosine squared into 1 minus sine squared. And then, I'm going to simplify a little. And then I'm going to add sine squared to both sides. And I'm also going to subtract 2. So now we've got sine squared x plus sine x minus 2 equals 0. Factor that. There's a helper for this, in case you're confused. It's sine of x plus 2 times sine of x minus 1 equals 0. So either sine of x is negative 2 or sine of x is positive 1. Sine of x can't be negative 2. The smallest sine ever gets is negative 1. So we don't need to continue with that. The only solution will be the one where sine of x equals 1, and that happens only at positive 90 degrees. Sine x cotangent x equals square root 3 over 2. Now we're solving for the entire circle in degrees. This is one where you really want to use your identities. Hey, look, if I replace cotangent x with cosine over sine, I just get cosine is square root 3 over 2. That happens on the unit circle at 30 degrees, but also at 330 degrees. That is 30 degrees up angle, 30 degrees down angle from the x-axis. Number 10, cosine 2x equals sine squared x minus 2. Not only do we have cosine and sine, but that's cosine of 2x, which is weirder. But this is a place where the double angle identities come in really handy, and where the fact that cosine has 3 of them. So remember, we could use cosine squared minus sine squared. That doesn't really help. We could use 2 cosine squared minus 1. That doesn't really help. But if we use 1 minus 2 sine squared x, go look it up on your sheet. That's one of the identities. Now we're only dealing with sine. So let's get everything on the same side. We'll add sine squared x, and we'll subtract 1. And what we get is 0 equals 3 sine squared x minus 3. Factor out the 3, and we get 3 times sine squared x minus 1. Divide both sides by 3. 0 divided by 3 is still 0. So sine squared x minus 1 equals 0. You can look at the helper for this, but this basically means that sine of x is either 1 or negative 1. And that happens at 90 degrees, and then again at 270 degrees. All right, solve for the entire circle in radians. So there's a helper for this also in the helper video. We're going to add 1 to both sides and divide by 3. Tangent squared x equals 1/3. That means tangent x equals plus or minus the square root of 3 over 3. Again, I explained where this comes from in the helper video. That happens at, let's see, 30 degrees, which would be pi over 6. And then again in the third quadrant at 7 pi over 6. 2 sine squared x equals 5 sine x plus 3. We want to get everything on the same side. 2 sine squared x minus 5 sine x minus 3 equals 0. There's a helper for this as well. It factors into sine x minus 3 times 2 sine x plus 1. So either sine of x is 3, which is impossible, or sine of x is negative 1/2, which is entirely possible. That happens at, oh dear, no, that's right, sorry, talking to myself, at 7 pi over 6, that's in the third quadrant, and then again in the fourth quadrant at, 11 pi over 6. Solve for all real values. This one is a little funny. We got sine squared of 2x. We had a formula for sine of 2x, but not sine squared of 2x, but that's okay. Sine squared of 2x just means sine of 2x squared. So I'm going to replace sine of 2x with that formula, 2 sine x cosine x, plus cosine squared x equals 0. Now I'll just square this whole thing. So now this is 4 sine squared x cosine squared x plus cosine squared x equals 0. I could replace the sine squared with 1 minus cosine squared, but actually we don't need to, because since both of these have a cosine squared, we're going to factor it out. Cosine squared x times 4 sine squared x plus 1 equals 0. So either cosine squared is x, cosine squared of x equals 0, or sine squared x equals negative 1/4. Square root of 0 is still 0, so cosine of x is 0, and that happens where? That happens at 90 degrees, and we're looking for all real values, so it's plus 360k, and again at 270, plus 360k. Sine squared of x equals 1/4, that means sine of x would be plus or minus I over 2. We are not dealing with imaginary numbers here. We don't want them. So the only values are these, 90 plus 360k, 270 plus 360k. Number 14, this is again a factoring. Here, this will be tan x plus 1. Basically tan x plus 1 squared. It's tan x plus 1 times tan x plus 1. Take the square root, you get tan x plus 1 equals square root of 0 is still 0. Tangent of x is -1. Where is tangent -1? Well, that happens in the second quadrant at, we could use radians or degrees, it doesn't say, so I'm just going to use radians. So the second quadrant at 135 plus 180k. And then in the fourth quadrant, but in the fourth quadrant it happens at 315 degrees, which you'll notice is 135 plus 180. All the tangent values occur 180 degrees apart, so for this one you only have to put that. But if you also say 315 plus 180k, it's not wrong. It's more than you have to do because this is included, but it's not wrong. Cosine squared plus 3 cosine x equals -2. So let's get everything on the same side. Go ahead and factor. This is cosine x plus 1 times cosine x plus 2. So cosine x equals -1 or cosine x equals -2. This happens where? This happens at 180 degrees plus 360k. This happens nowhere at all. And finally, a little inequality. So get cosine theta by itself. Cosine theta is less than -1/2. This looks a lot like the problem on the front, but it's cosine instead of sine, so it's going to be different. Let's think about our unit circle. Cosine is -1/2 where? Cosine is -1/2 at 120 degrees. And then also at 240 degrees. Sorry, I don't draw so well. All right, cosine is the x value. It's less than, so where is the x value getting smaller? To the left. So 120 is less than or equal to theta is less than or equal to 240. And that's it.